Okay, when you look at this problem, the fact that it's a parallelogram only tells you the following. This set of sides is parallel, and this set of sides is parallel. That's all you know based on the parallelogram. So if you do look at this, though, what relationship has to exist between angle A and B? What's it going to equal? 180, right? Because these are same side interior angles of parallel lines. So A and B equal 180. Well, what do we know about angles B and C? They also equal 180 for the same reason, right? They're same side interior angles of these two parallel lines. So based on that relationship, we could then make the statement that A plus B is equivalent to B plus C. Correct? And what would justify that? Substitution, or two things equal to the same thing are equal to each other. Transitive property. And now if you subtract angle B from both sides, we get the relationship that angle 1 and angle C are equal by subtraction property. And so we see this relationship here that opposite angles in a parallelogram are going to be equal. And you guys should have seen that in your calculations on Sketchpad. Okay. The same exact line of reasoning works for B and D. Okay. Now, if we were to draw in a diagonal in this triangle, so let's say we draw in AC. Okay. We now split this parallelogram into two triangles. Okay. Those two triangles share side AC. Well, the fact that AD and BC are parallel to each other means if I were to label these angles 1, 2, 3, and 4, what do you know about angle 1 and 4? They're what type of angles? Angle 1 and 4 are AIA. They're alternate interior angles of parallel lines, therefore they're equal to each other. So we know that these two angles are equal. And what about the fact that AB and CD are parallel to each other? What do we know about angles 2 and 3? Same thing, right? Angles 2 and 3 are alternate interior angles. So this angle and this angle are equal as well. Well, when we're looking at the relationship of triangles here, we now have a pair of angles and an included side. Is ASA a congruence pattern? Yeah. So we can say that triangle ADC is congruent to triangle what? What point in the other triangle ABC corresponds with A? This angle 1 corresponds with angle 4, so that's point C. Okay. Angle D is this angle with two tick marks, so that corresponds to B. And then angle C down here, angle 3 corresponds with this alternate interior angle 2, which is point A. So by ASA, we're able to establish that these two triangles are congruent. Therefore, when we look at opposite sides, so let's say AD, what side does AD correspond with? BC, and those are equal to each other. So opposite sides of a parallelogram also are equal. Okay. So AB right here corresponds with DC. So we see that both pair of opposite sides in any parallelogram will be equal to each other. Okay. And then the final step is if we took this figure and we drew in our second diagonal. And let's say we call this point E where those diagonals intersect. If we look at these two triangles, so we have this triangle AED, and we have this triangle BEC. In looking at those triangles, we already have one pair of sides equal, the opposite ones. We already have a pair of angles equal. Angle 1 and angle 4 are equal. Well, what do we know about these vertical angles here? They're equal. Vertical angles are equal. So we have two angles and a side. Is AAS a congruence pattern? Yeah, so we can also go through and make the statement that triangle ADE is congruent to triangle, again, what does A correspond with in this lower triangle? C. D corresponds with B, and E corresponds with itself. Okay, and so by AAS, we can state that those two triangles are congruent. And so when we're looking at these diagonals, BE is equal to DE, so these two sides are equal. And we see that AE is equal to CE, so AE and CE are equal. So what's happening with those diagonals? AC is cut into two equal parts, BD is cut into two equal parts. So the diagonals of a parallelogram will always bisect each other. Okay, so those three properties will be true for all parallelograms, no matter what type of parallelogram you're dealing with. It's true of a rhombus, it's true of a rectangle, it's true of a square. Is it true of a trapezoid? No, because a trapezoid's not a parallelogram. So anything that's a parallelogram will have these three properties.